Hi everyone. In this video we're going to be working on the integral test as well as the p-series. Now, the reason why we work on the integral test is when we're trying to figure out if a series is going to converge or diverge, it is very important to figure out which test we have to do first. Now, the reason why we do the integral test and when we know when to use integral test is anytime that you can actually integrate your series and you realize, oh look, this can be integrated, I can find the antiderivative of this, you're going to apply the integral test. Now, the integral test does have a little bit of work. It is not an easy test. The reason is you have to first determine if it's continuous, positive, and decreasing. Now you have to go back to calculus 1 whenever you're trying to figure out if something's decreasing, and that's usually by the first derivative. If you're able to determine if it's continuous, positive, as well as decreasing, then that means that your series and your integration of your series, because f of n is going to equal to a of n, will both converge or diverge as long as you're able to integrate it. Now, the one thing you want to remember is that this does not necessarily give you a sum. So we could do all of the work and we still won't have the actual sum of what the series is going to add up to. But we will know if it's going to converge or diverge. So, let's go ahead and do our first example. Now, in our first example, our first thing is we have to ask ourselves, is the function continuous? Now, you'll note that this is a rational function. So because of that, the only part that it's not going to be continuous is at the VAs. So I'm going to set the bottom equal to 0. And I'm going to get n cannot equal to 1/3. Which means that your function is continuous except at 1/3. Then you can ask yourself, well, does that really matter to this series? Not really, because we're starting off at 1 all the way to infinity and 1/3 is not in between that. So that means this is going to go ahead and check out. Our next thing is this positive? Well, the one way I can figure out if it's positive is let's plug in our first term, n equals 1. So my first term is going to be 2 over, plug it in, I get 2, which is 1, and that is for sure positive. That checks out. And the reason why I don't have to check anything else is because no matter what number I plug in from 2, 3, all the way to infinity, that's always going to give me a positive number. So this is always going to check out. Now my last one, the one that's going to give me a little bit of trouble, is it decreasing? Now remember what I said before, the only way to determine if it's decreasing is I have to apply the first derivative. Now I can apply the first derivative, low d high minus high d low, which is going to be 3n minus 1 times the derivative of the high, which is just 0, minus the high times the derivative of the low, which is 3, all over low squared. So this is going to give me negative 6 all over my denominator. And you'll notice that this is my y prime. And then you have to ask yourself, oh, when I find my first derivative, in order to determine if it's increasing or decreasing, I have to put numbers on a number line. Not necessarily true for this example. Because no matter what number I plug into the bottom, I'm always going to get a positive because it's being squared. The top is always going to be negative, which means that this function is always going to be decreasing. So I get my third check mark, which now lets me know I could actually apply the integral test. And the reason why I need that is because I could integrate this. This is just a u substitution. So now my new problem becomes this. The integral from 1 to infinity of 2 over 3n minus 1 respect to n. But the one thing you have to remember is you cannot integrate something that has an upper bound or a lower bound with infinity. So I have to rewrite this. So that's going to be limit as b goes to infinity. The reason why I use b is because remember this is from a to b and I'm changing the upper bound 1 to b of 2 over 3n minus 1 dn. Now you'll notice I can probably take that 2 out and you'll notice that I can set a u substitution with the bottom. So I'm going to take u equals 3n minus 1, du over dn is equal to 3. So that means that dn is going to equal to du over 3. And then I'm just going to plug everything back in. This is going to be limit as b goes to infinity of 1 to b 2 over u du over 3. Now my next thing is I don't want that 2 and the 3 there. Like I said before, I can take it out. This is going to be a limit as b goes to infinity of 2 over 3, the integral from 1 to b of 1 over u du, and when you integrate that, you'll notice that this is just going to be ln. So then this is going to be limit as b goes to infinity, 2 over 3 of ln absolute value of u, upper bound minus lower bound, which I'm going to plug in now. And you'll probably notice that ln of 1 is just going to be 0. So my last thing that I'm left with is a limit from b minus 1 is just going to be left with ln absolute value of b, which means I'm going to plug infinity into there, and that's going to be 2/3 times ln of infinity. But ln of infinity is going to be infinity times 2/3, which is still infinity. So that means that my series is going to, the sum is going to go to infinity, which therefore means this is going to diverge. And that's because when I found all the sum of every single term, it's going to give me a number so big that I cannot determine, which means it's infinity. So that means that my original series of 2/3n minus 1 is divergent. So in a problem like this, you have to take account that if you can integrate this and you realize I can integrate this, that means that you first have to determine if it's continuous, positive, or decreasing, because if one of these do not check out and there's no number that you can use, then I can't use this test. So this problem does require a little bit of work. So we're going to do the next one, and you'll realize what I mean by all of these three have to check out, and maybe you can make something to make it all check out. So in our next problem, we have ln of n over n to the fourth. First thing is, can I integrate this? Yes, you should remember that you actually were able to integrate this in one section, and this was called working with u times. Now, once you realize that you can integrate this, your next thing is you have to find out, is this going to be continuous? ln of n is continuous everywhere from every number greater than 0. And that's, you have to go back to working with pre-calc graphs. And to the fourth, the only number that can't be is 0. Both of these numbers, this is greater than 0, this is 0, meaning that this is not fit in this bound. So that means that this is going to be continuous. So check mark. Now we have to figure out if it's positive. Well, I can always plug in my first term. When I plug in 1, I'm going to get ln of 1 over 1 to the fourth. But if you notice, ln to 1 is 0 over 1. That is not a positive number. That actually gives me 0. So as of right now, it doesn't check out. So then I have to figure out on the number that this is going to check out for. So let's just plug in the second term. ln of 2 is going to be a positive number over a positive number, which is a positive number. So this does go ahead and check out. Now, one thing I can't do is I can't start off with my integral from 1. Because when I started off at 1, it didn't give me positive. So now I have to check it off at 2. And you're able to do that, and that's fine, because one thing about the sum is it doesn't matter if you start off at 1 or a random number, as long as it fits all characteristics, which is continuous, positive, and decreasing. So my last thing is that the term is decreasing, so it's going to be low times d high minus high d low. So n to the fourth times the derivative of the high, low d high, which is 1 over n, minus high derivative of the low over low squared. But I'm not going to write it because I have to do a little bit of algebra. So n to the fourth times 1 over n is going to be n to the third. I'm going to rewrite this. I can factor out n cubed, which I am. Now, since I cannot do anything else, I'm going to put this over low squared. So that's n to the fourth squared, which is n to the 8. I'm going to simplify this. This is going to be 1 minus 4 ln n all over n to the fifth, and that's my first derivative. Now, because you have a problem like this, you have to figure out your critical numbers. Critical numbers are found by setting the top equal to 0. So 1 minus 4 ln equals 0. 1 is equal to 4 ln of n. 1/4 is equal to ln n. And then you have to ask yourself, how do I get rid of that ln so I can get n by itself? Don't forget it's e. So it's e to the 1/4 equals to n. And if you convert e to the 1/4, that's going to give you a number around approximately 1.28. So that's my critical number. Now I have to find my undefined point. Setting the bottom equal to 0. N cannot equal to 0. So that means that these are my two numbers on my number line. 0, 1.28. I'm going to check boundary. So that means I have to check left of 0, middle, and right. Now the reason why I'm not going to check left of 0 is the fact that if you check left of 0, that's not even in my balance from 1 to infinity. So what's the point of even checking that? So this is just a waste of time. Now, I'll check 1, but you should probably notice that 1 didn't really matter because you see how 1 didn't give us a positive number, it gave me 0. I couldn't even use 1 in my balance, so I won't really have to use that. But let's just plug it in just in case so I can show you something. When you plug in 1 into here, you can get 1 minus 4 ln of 1. You gotta remember, ln of 1 is 0. So that's just gonna be 1 over 1 to the 5th, which is 1, positive. That means this is gonna be increasing. So this 1 doesn't even help us out because it's increasing. We need to determine if it's decreasing. So I'm gonna plug in another number, which is 2. I'll plug in 2 into here. That's gonna be 1 minus 4 ln 2. So if you stay with me, minus 4 ln 2 is going to be a big negative number. So 1 minus negative is going to be a negative over 2 to the 5th, which is positive, so this equals a negative, therefore this is decreasing. So my interval of decreasing is 1.28 all the way to infinity. For positive, it wasn't positive at 1, it was positive at 2. So I can pick any number to start off with in my integral. So what I'm going to do is I'm going to start off at 2 since it worked out for all 3 of these. So then my integral is going to be from 2 to infinity of ln n over n to the 4th. But once again, I can't have that, so I'm going to change this to the limit as b goes to infinity of 2 to b ln n over n to the 4th dn. So this is not an easy method. It's not at all. But the problem is this is the only method that we could use as of right now. When you have an integral test, the hardest part of it is determining where it's going to be decreasing. It is not easy. You have to be really conscious of all your work and careful that you're not going to make those little mistakes. But when you notice that you can integrate this, you're going to use the continuous, positive, and decreasing to determine if I'm able to use an integral test. Since they all checked out, they were all continuous, positive, and decreasing from 2 to infinity, so that's why I picked 2 as my lower bound. I changed my upper bound because I couldn't have an infinity. Now my next thing is, okay, well let's actually integrate this. But you have to remember, the only way you can integrate this is using the u times the v minus the integral of v du. Where you have to ask yourself, okay, what is my dv? Well, remember, dv is the thing that you can actually integrate. You have 2 options. You have this option or you have that option. If you notice that you could actually integrate dv, so this could either be u, this could be v. This is the part that I can't integrate. I cannot integrate ln of n. I have no idea how to. So that's why this is definitely not going to be ln. This is going to be n to the 4th. Now my next thing is I have to figure out what is going to be my u. My u is what I can actually find the derivative of, which is ln of n. Now my next thing, when I have that, is let's actually go ahead and integrate dv. So this is going to be v is equal to n to the 5th over 5. And let's go ahead and find this derivative. So it's du over dv is equal to 1 over n. Get du by itself. And I have my solutions as of right now. So now I'm just going to go ahead and plug things in. I have my u, I have my v, and now I have my du. So substituting everything in, I'm going to have ln of n times n to the 5th over 5 minus the integral of v, which is the same exact thing I just wrote down, times du. And I have to simplify this a little bit. So when I simplify this, this is going to give me n to the 5th over 5 times ln of n minus, this is going to cancel out. I'm going to take out the 1/5. And don't forget, your bounds are still what we have before, but I'm not going to write them as of right now. So this is going to be n to the 4th dn. Now I can integrate this. This is now going to become add 1 to the exponent. And this is going to become n to the 5th over 5 ln n minus n to the 5th over 25. All bounds want b to, sorry, not b to 1, b to what we picked before, 2 to b. So I'm going to substitute everything in, and when I substitute everything in, I'm going to get this. The limit as b goes to infinity of b to the fifth over 5 ln of b minus b to the fifth over 25, all being subtracted by me plugging my lower bound, which is 2, so 2 to the fifth over 5 ln of 2 minus 2 to the fifth, 25. So now finally I can actually go ahead and plug in this infinity, which is going to be, if you notice, if I plug infinity to all of these numbers, I'm going to get infinity minus a certain number, right? Because this is going to give me a number. But infinity minus a number is always going to be infinity, which means therefore that this is going to diverge. So all this work just to figure out that this is sum is going to give us a number so big that we don't know what it is. So then that means that our original series of n equals 1 to infinity of ln n over n to the fourth is divergent. Now, by no means this is an easy test. It's not. This is actually one of the harder problems that you're going to be dealing with anytime you have to apply the integral test. But if you could actually work with this problem and understand that it's continuous positive and decreasing for a certain value all the way to infinity, and the fact that you're able to integrate a very difficult problem, this is going to be the hardest that you're going to see. Okay? Now, the last thing that we're going to be doing in this video is discussing p-series. Now, p-series is a problem where it is 100 times easier than the problems that we've done so far. P-series is in the form 1 over n raised to a p. The reason why it's called a p-series, in my belief, is the fact that your number, the number that you're plugging in is in your exponent, which is the power. So this is why it's called a p-series. Now, if p is greater than 1, so if this number is greater than 1, it will converge. It has to be greater than 1, and it has to be in this format. Now, if p is less than or equal to 1, this series will diverge. So it's just memorization. You have to just memorize that if p is greater than 1, it's going to converge, and if p is less than or equal to 1, it's going to diverge. Now, there's a special case that when p is ever equal to 1, it's called a harmonic series. And it's just something you want to understand and know because it's an equation that you use a lot, and it has a lot of everyday value. So what we're going to figure out is, okay, is this going to converge and diverge? I have no idea. Well, one thing I'll notice is 1 over n to a power. Well, what is my power? P is equal to 3. The fact that p is equal to 3 means, I'm going to go back to my rule, that's greater than 1, so this will converge. And that's it. Once again, I don't know what this is going to converge or diverge to. I just know that for sure this is going to converge. And that's the one thing you want to make sure you take out of all of this stuff. A lot of times you're not going to understand where it's going to converge to or what the sum is going to be of the series. But you will know that there is going to be a sum that's going to go to a finite number. Now, last case. This kind of looks like 1 over n. The problem is it's not a power, it's a cube root. Well, I can definitely rewrite this. Isn't this the same thing as me just saying 1 to the third? Well, now I have that form to a power where my p is equal to 1/3. And then I'm going to ask, okay, is it greater than 1 or less than 1, which is definitely less than 1. That means that this series of 1 over cube root of n will diverge. So, once again, you do not know if this is going to converge or diverge to a certain number. Diverge definitely probably infinity, but you won't know if it's going to converge. You have no idea what it will converge to or what the sum is going to be. But you do know that this series will converge or diverge based off by just looking at the power. This is one of your easier tests. And that's pretty much it for p-series. So, going back to integral test. Integral test is a very difficult test. You have to be very careful of everything you do with integral test. Now, one thing you want to make sure you understand for integral test. If it's ever continuous, positive, and decreasing, and you can integrate this, you're going to choose this method. The more difficult one that you're going to be working with is any time that you have to determine if it's decreasing, because that's going to be your first derivative test. Now, once again, this will not necessarily give you a sum. This is just going to let us know that this is going to converge or diverge. And p-series, anytime you notice that your p is greater than 1 or your p is less than or equal to 1, it's going to tell you automatically it's going to converge, diverge. Once again, you do not know what it's going to converge to. You just have to know that it's going to add up to a certain number if it converges. and it has to follow this form. Okay? So, thank you for watching. Hope it helped. And let me know if it worked.